want to talk specifically about this project, serverless.tf. So what is serverless.tf? As you can imagine by name, it is doing serverless with Terraform. I want to explain why I actually started this project and what this project actually consists of. So I'm not sure if I use a lot of words frameworks here, because when I was making this one, I looked into definition of what does framework mean. And framework actually means not just tool, but it's actually a concept, it's a way of doing something. So it is not CLI, it's not any shell script or Python or anything like that. It just concept describes how things can be done and what are actually the problems with existing solutions. So in my company, which is called Better Job, we do a lot of serverless nowadays, primarily because it's cool and I don't like to manage VPC resources anymore. And the thing with existing solutions is that when we started using it, so we have few projects where we use serverless framework, and we always felt like this doesn't belong here. We understand two things: how to write Terraform code and how to write Python code. That's it. We don't know anything of Node.js ecosystem. And if we want to do something, please don't let us to learn how Node.js work or how plugins has to be added. So this is definitely not what we wanted. There were already many different things available, like framework to write this code, which actually generate some TF code or CloudFormation code for you as well, which is, well, I don't really want it. And then there are tools for infrastructure management, and then we use something to do application deployment. So in serverless.tf approach, we just decided that everything what we have is just one big graph. And we want to let Terraform to go through this graph and make all of this as one big bang, let's say, comprehensive infrastructure management, and to do serverless application deployment. Because all our infrastructure in serverless consists of different infrastructure resources and application code. That's it. It doesn't contain anything about plugins because we use just Terraform resources natively. So there is no need for us to think about concepts which are introduced by any of serverless application frameworks. And initially it was like a little bit too much. So we thought like, okay, we probably need to use Terraform and we need to use some sort of application framework which will help us to write this application code. It turned out that the most useful framework is the smallest one. So we like AWS Chalice, which is very, very small and very minimalistic. It has some relation to CloudFormation or to Terraform, but it's so optional that we can easily disable it. So we use TerraGrant. It says use Terraform with or without TerraGrant. Well, we use TerraGrant quite extensively all the time. And then there was a dilemma between Terraform and CloudFormation, sorry, not Terraform and serverless framework, where this resource has to be defined. Like API gateway, where does it belong? Well, it belongs only to serverless resources. So naturally, it has to be part of application framework, right? Okay, but what if I want to make like shared resources like VPC? Because you can create them inside of your serverless framework as well, but traditionally we create them using Terraform. So, and there are a lot of situations when you actually don't think or don't know where to write this. For example, DynamoDB. Does it belong to serverless application or does it belong to your traditional shared stack? So instead of thinking about where to put this resource, we just write code in Terraform, and now all what is related to infrastructure management actually defined as Terraform or TerraGrant. This one I don't really agree anymore because local stack is not great, especially free version. But it is possible to run similar copy of your environment locally if you wish. We are using different services which cost money on local stack, so we didn't bother to go with this approach. So most likely I will remove this text, but it is still a rather slow application development lifecycle with any of existing solutions like serverless framework. There are a few solutions in serverless framework approach like serverless components, which they are developing, and a bunch of different shortcuts which you can take. The point here is that we want to write code and we want to see a result as soon as possible. And applying this without generating crazy amount of CloudFormation code, then wait for something, we don't really want. We just want to run Terraform apply, and as soon as it finishes, the code should be deployed. So local stack is not actually helping us so much. And this one was a really big one. When we wanted to add functionality to serverless framework, I don't want to learn JavaScript. Really, don't make me to look into JavaScript code if you don't want me to cry, honestly. This is one technology which I don't want to add simply because a tool which I'm using has plugin written in that technology. So this is really important that our technology stack is not including JavaScript. So if we want to add functionality to add, let's say, AppSync or new features into API gateway, we don't want to write code and then maintain it somehow. We want to write Terraform because resources which we are going to add are part of infrastructure. So again, Terraform is native choice here. And then I already have contributed and used a lot of Terraform AWS modules, so which is just natural for me to continue using them. While doing this, I added few other modules like AWS AppSync to support. I think actually now it supports. Now it supports all features of AppSync, including all ways of authentication, all kind of resources, resolver, data sources, and so on. And then I added another module which was also relevant for serverless, which is CloudFront. Again, CloudFront is used with Lambda at edge and so on. So AWS Lambda is a core component in all of this. So let me just scroll through this. Well, there are a lot of modules which existed before, but we added AWS Code Deploy because we wanted to deploy this again using just code. We just run Terraform apply, wait a few minutes, and then this Lambda function or set of resources which Terraform decided to be related updates. That's it. Again, we rely on Terraform all the time to manage our infrastructure. And now we just add another resource, which is called Lambda function, for example. It has a bunch of dependencies, which are described already. So let Terraform to resolve this somehow. So let me show this source code of Lambda module. So this Lambda module was created with an idea that we want to be able to do everything what is related to AWS Lambda tasks, like building dependencies in Docker, without Docker, private repos, public repos, doesn't matter. Then we want to take care of packages. We want to have them locally, or we want to upload them on S3. Then we want to make sure that we actually update this Lambda function every time when something changes in dependencies. This is still a little bit tricky part sometimes. And then we want to do deployments using submodule, which is called somewhere here, it's called deploy. So there is module which is called deploy. So in fact, there are a lot of different combinations. I call them countless, but of course you can count them. And overall, I look into this as like the most complicated piece because this module takes into account Terraform lifecycle as well. So for example, when we run Terraform plan, what do we expect? Well, we were told that nothing will be created. So that's true. No resources, no zip archive, nothing will be created because you run plan. what happens if you remove this plan? Well, this plan has to be not created again, and there shouldn't be any hard failure. It should resolve somehow. A lot of magic has been placed into a package Py script, which is now pretty long, but it's quite easy to understand when we are working with it. So, and also there are a lot of different examples which show how these can be used. For example, if I go to complete, well, complete usually shock people because there is one function with enormous amount of input parameters, and in fact, of course, normally we don't use all of this, but it just it's supposed to show you amount of features which are inside. Normally, when we deploy Lambda function, and the code looks like this. So we just specify, okay, this is for layer. So the code looks like this: function name, source. Do we want to publish it? That's it. So not much, not a lot of things different, but amount of all of these combinations and options and different dependencies is just crazy. So when we started working on this module, we obviously looked at existing solutions, and then we figured out that, okay, the best solution which we found has a lot of challenges. Like I think the one by ClaraNet, I think Clara. Well, I don't remember Clara. Anyway, I think it was
You're
mentioned.
right. It's the one by Clarinet. Yeah.
Yeah. So they have a lot of open issues, and we looked at those issues, and we figured out that the whole approach, which is implemented in that module, has to be implemented like one more time completely, because we understand we take into account Terraform lifecycle, like plan, apply, destroy is essential here. We cannot just say like, oh yeah, we are building Lambda function, so we assume that you have this source code available. No, if this source code is not available and you run plan, fine, you don't need it right now. But if you run apply, then yes, we will check it out and we will see that something is missing or some arguments are not correct. So amount of values which we have somewhere in package is just crazy. So here is a relation between external data source, including all of its strange behavior, local file, which contains information about what is actually about to happen. It's really helpful for debug. And then we actually rely on null resource to create an archive. We cannot rely on traditional, what was it, zip archive or some sort of built-in resource, because it lacks significant amount of features, like excludes, like enormous amount of features. I don't remember right now, but we couldn't use it. So that's why there are a lot of strange dependencies everywhere. Now I say that it works, but when I don't work on this project for some time, I forget how it's built. So luckily there are examples, and I'm sure that you guys understand what I mean by forgetting how things were built. For me, this happens quite often when I switch focus and I forgot how things were created or who made it, and then I see my name. Oh, okay.
That's how it is.
So, yeah.
More projects.
So I encourage you to check out this one, and amount of features which we put here, an amount of integrations with not just HTTP API gateway, but also with AppSync and CloudFront and so on, is pretty big. So I tried to write documentation and actually explain how to do different things like debugging, how packaging actually works, and so on.
So let's take a pause there for a moment and let's see. I'm sure there's some questions here maybe. Anybody have some questions for Anton and his implementation here of the serverless style framework?
This is Sheldon. I've actually been working through this this last few weeks. Have not used your solution yet. I'm definitely going to go try it out. What I would like to know is that one of the reasons for me that being new to Lambda, that I haven't gained much momentum on doing a lot more, is the plumbing, right? You know, getting all of the steps, all the permissions and setup. And the serverless CLI, my first attempts with it were pretty straightforward, pretty nice, as nice as it could be using something that I prefer to use Terraform in. What I would like to know is just on a very high level, if somebody is familiar with Terraform, they're not familiar with Node, anything like that, but I'm not creating plugins. Where do you see the benefit of approaching it with a module like this versus something like the serverless CLI? What's the sales pitch in a way that helps me, you know, decide what fits my use case better?
Well, I think the best sales pitch, which at least stick in my head, is that Werner Vogel told us that serverless should be easy, but talking about serverless and dreaming about serverless is totally opposite of using existing serverless ecosystem tools. So you manage to do your job quite easily, straightforward, using serverless framework. But if you continue doing that, and if you suddenly decide to expand it, you will have to go deeper, 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 and fix plugins and try to debug something. And it's just much, much slower than traditional case which we have with Terraform.
That was my experience with serverless also. I started using it a while back, and yeah, it looks real good when you first get started. It's very, very easy. But then as soon as you need to do something that is just outside of whatever plugins you chose, you know, actually support, like you got to go, you know, learn that JavaScript and really dive in to figure out, you know, how to adjust it to address your use case. Whereas with Terraform, you know, like it's all in Terraform. It's exposing the entire AWS API to you. You can do exactly what you can do with AWS and the AWS console, you know, in Terraform. So it's way more powerful, gives you a lot more control.
And in the
One
end,
other question: does this run in Terraform Cloud, or is it do a lot of local provisioner type actions that require it to run locally?
Well, today I was trying to figure out this. There are Terraform Cloud agents which cost money, and this is the only way how you can install Python there. From what I understand, there is no easy way to provide your own dependencies. So Python is required.
You can bundle all the binaries and things you need in your repo, and if it's totally, what's the word I'm looking for? Self-contained, it'll work, but that's not scalable.
Well, you can also do something crazy. We can elaborate on this. So here is this piece of Terraform Cloud agent. So you have to use this TFC agent latest and then just install Python 3.8.
That's with the agent, but like if you're just going to use open source Terraform, not open source, but the public Terraform Cloud, not including runners, then yeah, that would be tricky.
Well, you can do this still, but that's definitely ugly and probably outside of this scope.
Yeah.
There's kind of an interesting way to get anything you want into Terraform. Also, you can create a module that contains exactly what you want, but that has no Terraform code, right? And then you include that module as a source in your main.tf, and it will go download that Git repo for you and pull it local.
I like it. That's a pretty clever hack to do
It's
it.
definitely a hack. But it's kind of a fun way of vendoring. Like, I wanted to. There's some JavaScript-based lambda, that I want to deploy using Terraform. So I put a module around it as the source, as the Git repo. It pulls it in for me, and then I set that as the source path for the Terraform code.
Yeah. I have a question for you, Anton. I'm curious. When I saw you going down the path in the intro there, and I saw you were introducing code deploy, and you were using that as part of the solution. I got excited because I thought maybe what you were going to do was because the local exec thing, I get it. I know why you're doing it. Been there. We're doing it for some things. But what I was hoping to see was that you use something with like code build or code pipeline or something like that to construct the artifacts in such a way where you have no local dependencies other than the Terraform binary.
This will take time. That's what I don't, and this will introduce different dependencies in between. What I can do is that if I uncomment this block, this is like playground where I have a bunch of things in one place. And if I do deployment here, then here I just specify which version I want to deploy and what else. Yeah, and just apply this change.
Okay, so that's kind of doing the remote build that I'm talking about.
Yeah, but this is going to be using code deploy through AWS. Yeah, I think I use AWS CLI here to do that.
Oh, okay. So it's shelling out to AWS CLI.
Yeah.
But then running the rest remotely.
And here is also wait deployment completion equal true, which means that I will actually sit and wait until this lambda canary deployment deploys everything.
Yeah.
So which is a pretty effective way for me to sit and do nothing and just sit and wait and wait. So normally I set wait deployment completion to false and continue doing my other things. So this one.
Yeah.
If you haven't seen it yet, the original maintainer of the Clarinet Lambda module, his name's Raymond Butcher. He's in the sweetops Slack also.
Oh, cool.
So he's created another Lambda module under his own GitHub account called AWS Terraform AWS Lambda Builder, and it is actually doing that. It's using a Lambda function to build the Lambda function, or optionally a code build project.
Okay.
Build the Lambda function. Yeah.
Yeah, it's actually very interesting that you mentioned this, because when we were writing this Python code and crazy amount of dependencies, we were really looking forward to see and to figure out why it is so hard to do with Terraform. Because okay, Terraform was not designed for this. Fine, I get it. Then I was looking for something like Terraform AWS Lambda provider. So there is a special provider for just that provider.
Wait, like executing lambdas to run arbitrary things and get the out?
No, it's actually to this one, AWS Lambda. What is it? Resources. So invoke custom Lambda function. And I was really thinking that there should be some sort of higher structure inside of native AWS provider where we can say like, hey, this is archive. I want this function to be created. Mm-hmm. In fact, we need to connect all of this packaging, building, and so on. That's where Pulumi say like, guys, take my beer and we will do this properly, as well as AWS CDK.
Yeah.
So yeah, I'm looking forward when this AWS Lambda provider, I mean, of course, with significantly different features, but when Lambda resources will be properly integrated and supported inside of AWS provider. Because what we do now definitely not gonna to be acceptable for people who cannot or don't want to install Python.
Yeah.
So I don't know how to explain to them that, hey, Python is good, please install it. One more thing which I kind of forgot to say is that when you go to serverless.tf and you read some basic things which I just went through, you can click on the link and read more about all of these steps in details, like why this was built and what is actually, law of conversion of complexity. You see, I was using Wikipedia to find this link. So you can read about this, and probably it will give a little bit bigger picture of how Terraform fits to this field. So I put a little bit more information here, including development workflows and how things are connected together, and using commands like SAM build, because I was actually considering to look into SAM build more, but then I discovered that it's, again, not good choice for us, and so on. So check it out. It's a little bit long, but I think it's helpful.
That's really helpful that you documented all that research and design considerations that went into it and what led you down the path.
Yeah, now we are actually using it. So I have to update it a little bit and remove some sections because I was over optimistic at some point on certain things like local stack, for example, which is absolutely not good fit for this case. So yeah.
Local stack is a good fit for very few use cases. It's local stack and the Minikube are the bane of my existence.
Yeah, generally agree with that. I think the promise is different from the reality, maybe.